Let's talk about the 7-layer OSI model, or Open Systems Interconnect model. The 7-layer OSI model is designed to help us conceptualize what's happening on a network, or group things into a few different categories so that we can kind of understand what's going on inside the network, which we can't really see, we can't really observe, we don't really know how it all works, but this is a way of conceptualizing what's going on. So the 7 layers are physical, data link, network, transport, session, presentation, application. Okay. Now each of these different layers kind of depend on all the ones beneath them, or in writing them 1 through 7 above them, to be in place. Each one doesn't really care about how the one previous to it does its job, but it assumes that it does. So for example, the network layer is all about grouping computers together and communicating between computers. It doesn't necessarily care about the physical connection between computers. All it cares about is that it can transmit information in a certain way. So it's not going to worry about the physical layer. It's going to assume that the data link and the physical layers are in place. It also doesn't care about what type of application is using it, or what type of transport protocol is using the network layer. It's just going to provide the services that it expects to use. All the layers above it are going to use it as it's intended to be used, and it just kind of assumes that everything below it is going to work. Okay. So let's start by talking about the physical layer. So I have two computers here, A and B. The physical layer is the actual physical connection between these two computers, which right now doesn't exist. Okay. Now we could draw a single line between the computers if we were connecting just a cable from one computer to another. Though more commonly in today's networking, we have some sort of a hub, a switch, a router, some sort of a network device that we plug computer A into and then plug computer B into. So there's a physical connection between these two devices. Now also on the physical layer is how the signals are actually transported from computer A to computer B. Now this wire commonly is going to be an electrical wire, an Ethernet cable or something like that, that's going to transmit electricity through all of these wires, through the device in the middle, between computers A and B. And so that's what the physical layer is responsible for, is making the physical connection and sending a signal between A and B. Now most commonly, that's an electrical signal. However, there's a couple of other options. This could be a fiber optic cable, and it might be sending light from computer A to computer B, representing binary digits, zeros and ones. It could also be a wireless connection, which is becoming increasingly common in today's world. It could be radio signals, in which case the physical medium is not actually something tangible. There's not a wire between the two computers. There's space, and we're moving a radio wave through space in order to transmit information from A to B. That's going to be our physical network, or our physical layer of the network, is the stuff that's actually transmitting the information. Now when we get to layer 2, we need to start to organize that information. So in layer 2, we're asking, well, we can send signals back and forth, but how do we actually know that this is computer A, that this is computer B? How do we make sure that computer B receives the signal from A, etc.? And so usually when we talk about layer 2, the big thing that we want to deal with there is MAC addresses. Okay, so a MAC address is going to be 6 hexadecimal pairs, so we might have something like AA, BB, CC, 012134, and this guy might be AA, 00, B1, D2, 45, 87123456. Okay, so they're going to have MAC addresses. Now this MAC address is a globally unique identifier. Nowhere else in the world is there a computer with the same MAC address as these devices. They have that MAC address. It is a globally unique identifier for that machine. And so this is how we address computers at layer 2. From the factory, they get stamped with one of these MAC addresses. Every Ethernet port, every wireless card, every network adapter gets stamped with a MAC address, and that is the MAC address of that adapter, globally unique. So now when we have a conversation between these two computers across the physical medium that already exists, we now have a way to say, hey, this is coming from A and going to B, and we can reference those computers with that MAC address. Okay? So at layer 2, we start to organize information into a frame. A frame is like an envelope or a container of information. It's a series of binary data that's going to start with the recipient MAC address. So if I'm sending something from A to B, I'm going to start it with the recipient MAC address, then I'm going to put in my MAC address, and then inside that frame I can contain a whole bunch of other information. But that way we know where that frame is supposed to go, and when B receives that frame, it'll look at those first 48 binary digits. It will know this frame is for me. It can then take that into the computer, process it, and if it needs to respond, it knows that it came from computer A and it can respond back. Now with MAC addresses, this device in the middle, which we call the lowercase h hub in the physical network, we may want to upgrade that to a switch. We'll talk more about switches at another time. But a switch is a device that works with MAC addresses in order to direct traffic according to MAC addresses, so it goes out specific ports. Okay. Now when we get to the network layer, we start to realize that with these globally unique addresses, every computer ends up being on the same network, which is a little bit of a problem since there are a lot of computers in today's world. So we need a way of grouping computers into what we call the local area network, or a smaller subset of the computers that are out there in the world. And so the network layer adds in IP addresses, and an IPv4 address might look something like 192.168.1.15, and this one might be 192.168.1.20. Okay. Now this IPv4 address is only unique on the network, or only has to be unique on the network. So elsewhere in the world, there could be hundreds of computers that have 192.168.1.20, but because this is going to be separated from the rest of the internet by a router, these addresses are going to be unique within the local area network, but they can be reused elsewhere. So maybe this guy is a switch, and now we've got a router who takes us out to the internet. Nice little cloud there. Okay. So the router is going to separate the internet from the rest of the local area network. These guys are going to be on a local area network, and now these two can have conversations with one another without having to worry about everybody else in the world being part of that conversation. Okay, so the network layer, all about IP addresses and grouping computers into logical networks. The transport layer is where information is divided into chunks or segments to be sent across the network. Remember that each of these layers is dependent on the layer before it to send information. So the physical layer is actually going to be sending the signal. The data link layer is where we have frames. At the network layer, we add packets, which have these IP addresses inside the frame so that we can understand where the packets are supposed to go, which computer they're supposed to go to. Inside those packets, the transport layer places pieces of information. The frames of the data link layer are a fixed size. Okay. So if we have a large file that we want to send, we can't shove it all into one frame because the frames are relatively small. So the transport layer is necessary to divide all of those, all the big data into small chunks that can fit inside of data link frames, inside of packets, inside of frames. Okay. And so our transport layer is going to divide up information. Now at this point, this is all happening. Transport through application is happening on a single computer before we actually get out to the network. Okay. So the transport layer is dividing up the information. The session is keeping track of a variety of conversations. Maybe computer A is not only talking to computer B, but it's also talking to websites out on the internet. How do we keep track of which conversation is which? Well, that's where the session layer comes in, keeping track of the conversations between devices and computers. The presentation layer has to do with formatting information. Now, back in the old days of text-based internet, this had to deal with fonts and languages and things like that. In today's world, the presentation layer is where we actually add encryption to data that we're going to send across a network. So if we want to keep a conversation private, or if we want to hide credentials so that we can pass a username and password without it being seen, the presentation layer is actually going to be where we encrypt that information so that it's hidden. The application layer is the layer where we as the user actually get to interact with the network. So if you have a web browser or an email application or a video game that uses networking resources, anything like that, that's the application layer. That's the piece that we interact with. So let's walk through these layers real quick, starting at the application layer, going down to the physical, and let's say that we're sending an instant message or a Skype message from computer A to computer B. So on computer A, we're going to have our application open. That's where we're going to type in our message, like hello, and then we're going to hit enter. Now, as we move down to the presentation layer, that application may determine that it needs to encrypt that particular message. So the presentation layer will go ahead and encrypt the information so that it is represented in a different way than the letters that we typed in the application. The session layer is then going to keep track of the conversation that we're having to make sure that any responses come back to that Skype application. The transport layer takes the message, as short as it may be, and it's going to divide it up into segments of information that are then going to be stored inside of packets. The network layer is going to create those packets with those IP addresses. It will add my IP address as the source IP address and computer B's IP address as the destination IP address. The data link layer is going to package that into a frame. The frames are going to have the destination MAC address and my source MAC address as the header for the data link frame. And then finally, it's going to actually leave my computer and be transmitted across the physical network through whatever networking devices we have. If this is a switch, the switch is going to jump up to the data link layer real quick to check those MAC addresses, see what the destination MAC address is, and forward that frame on appropriately. And then it's going to jump back to the physical layer as it leaves the switch, up into computer B. Computer B is going to look at that MAC address and say, yes, this packet was destined for me, so it's up in the data link layer. Then it's going to jump up to the network layer. It's going to unpack that packet, look at the packet header. Does it have my IP address? Yes, it does. Still for me. Then the transport layer, it's going to start piecing back together all of those pieces of that conversation at the transport layer in computer B so that it can reassemble that message. And part of the transport layer's job is making sure all the pieces make it there and that they make it there in the correct order so that B can reassemble the message as it was intentionally or as it was intended. Then the session layer, going to keep track of which conversation we're talking about so that my Skype message doesn't show up in a Chrome tab somewhere. It's meant for the Skype application, so it's going to send it that direction. The presentation layer might decrypt the message. If A encrypted it, computer B is going to decrypt it at the presentation layer. And finally, at the application layer on computer B, up is going to pop a little notification that computer A sent you a message, and hello is going to appear on computer B. So that's the idea behind the 7-layer OSI model. Each of these different layers has different devices that it's going to be dealing with, different pieces of the communication puzzle that it's going to make sure work. Each layer is individual. Now realize that many of these different devices are going to work at the different layers. For example, the computer uses all of these layers. A switch uses layers 1 and 2. A router is using layers 1 through 3 and sometimes even a little bit of layer 4. Right? So not all devices fit perfectly into a single layer, but it's a good way to kind of conceptualize what's going on here. Usually we talk about devices at the highest layer that they fit into. So computers are application layer devices, a switch is a data link layer device, a router is a network layer device, so on and so forth. We can also kind of figure out based on the addressing, if we're talking about MAC addresses, we're talking about data link. If we're talking about IP address, definitely network. If we talk about ports, it's going to be transport. If we talk about programs, application. All right? So lots of different ways that we can kind of group things into this model, but realize this model is here to help us understand how things work, what things are doing what, and we can kind of build off of the existing layers in new layers so we can take advantage of what those layers offer.